Hello and welcome to Stories of Science. Here, we look back on humanity's long journey to understand the world. The questions, the failures, and the breakthroughs that slowly changed how we see the universe and ourselves. We tell science as stories. Mimas, the moon that might be a rebuilt world hidden in plain sight. The moment it really broke into public attention wasn't because of a research paper. It was because of a single image. A small moon, perfectly spherical, and right in the center, a massive impact crater. It looked like something had punched it with impossible precision. And people didn't ask, what is this scientifically? At first, they asked, is this CGI? Because it looked almost identical to the Death Star from Star Wars. But here's the twist: this so-called Death Star moon was discovered back in 1789. And the person who found it had no idea how strange it would eventually look. Back in September 1789, William Herschel was doing what astronomers did best in the 18th century, staring at the Saturn system through a telescope. He was using a 40-foot reflector, top-tier technology for its time, basically, space-grade equipment for the 1700s. But even then, Mimas was nothing more than a moving point of light. No surface, no detail, no structure, just a dot. So it was logged and filed as another object in Saturn's system, nothing special at the time. And honestly, no one cared much. Astronomers were focused on the dramatic stuff: rings, big moons, obvious features. A tiny dot didn't make headlines. The name Mimas comes from Greek mythology, a giant. Ironically, the real object is only about 397 kilometers across, smaller than some countries. But astronomy has a funny habit: the smaller the object, the grander the name. Like calling a USB stick universe core processor. It sounds powerful. It isn't. Through the 19th century, Mimas stayed in the background of astronomy. No atmosphere, no eruptions, no visible activity. In other words, it existed, but stayed silent. Out of sight, out of mind, as the saying goes. For a long time, it was just a standard icy moon in the catalog. Then technology changed everything. In 1979, Voyager 1 and 2 flew past Saturn and gave humanity sharper images than ever before. But even then, Mimas didn't stand out. It was still too quiet. The real turning point came in 2004 with Cassini. Suddenly, Saturn wasn't a distant target anymore, it became a close-up laboratory. And that's when scientists started noticing something odd. Mimas looked too clean. Its surface is extremely bright, almost freshly painted in appearance, yet at the same time, it is heavily cratered. A strange combination, like an old rock that's been washed, but never repaired. The basic numbers are simple: about 397 kilometers in diameter, mostly water ice, and a density around 1.1 g/cm superscript 3. It orbits Saturn in about 22.6 hours. So if you stood there, a full day wouldn't even pass before it completed a full orbit. Fast, small, efficient. But its environment is anything but simple. Compared to Earth, it's tiny, but among Saturn's moons, it stands out in a very unusual way. Titan has a thick atmosphere, and Enceladus has plumes and a hidden ocean. Mimas has nothing obvious. And yet it shines unusually bright. One reason is Saturn's E-ring, a cloud of fine ice particles. These particles constantly strike Mimas at low speed and stick to its surface. So it's not really clean. It's constantly being resurfaced. Like an old object gently wiped every day, always looking new, but never truly changing underneath. Deeper models suggest it's an icy shell with a possible rocky core. But its density and orbital behavior hint at something more complex than a simple ice ball. We just can't see inside. Then comes the turning point. Cassini reveals something dramatic: a giant impact crater. The Herschel crater. It was fully confirmed only after high-resolution imaging after 2004. Before that, scientists only suspected something large might exist there. They were wrong about the scale. It's enormous, about 130 kilometers wide and 10 kilometers deep, with a central peak structure. It covers roughly 1/3 of the moon's diameter. On Earth, an impact like this would be catastrophic. An asteroid slamming into an icy body at high speed should have shattered it. But Mimas didn't break. It stayed intact, still spherical, And that creates a serious scientific problem. Why didn't it fall apart? Maybe ice absorbs energy better than expected, maybe the impact angle mattered, maybe internal structure played a role. But no model fully explains it. So it becomes a survival paradox. And visually, it's even stranger. The crater makes it look like something out of science fiction. When Cassini images were released around 2005, media immediately called it the Death Star moon. But scientists saw something different. Not fiction, but an extreme impact case study. One story, one data set. On the surface, Mimas looks quiet. No geology, no activity, heavy cratering, ancient terrain, almost like a frozen world stopped in time. But Cassini also found a contradiction. Its surface isn't completely static. Particles from the E-ring keep slowly coating it. So you get a strange result. Old terrain underneath, but a constantly refreshed exterior. Like an ancient building polished every day. High-resolution images also show apparent changes under different lighting. But those aren't real surface changes, just lighting and scattering effects. In other words, what you see is often not what is actually happening. Compared to active worlds like Enceladus, Mimas shows almost no dynamic signals at all. And yet the contradictions keep stacking up. A moon that looks dead, but survived an impact that should have destroyed it. A stable body in a chaotic system. A simple ice world that refuses simple explanations. And so the question becomes harder to avoid. Is it really just a dead, silent moon? Or is it simply a world whose silence we haven't learned to understand yet? When you look away from Mimas and its massive impact scar, something starts to feel off. Because this tiny moon, which looks like it's just casually passing through Saturn's rings, is actually doing something far more dramatic. It's quietly reshaping the entire ring system, and it never exactly applied for that job. Saturn's rings were first noticed back in the 17th century. In 1655, Christian Huygens correctly realized those ears around Saturn were actually a ring system. But it wasn't until the late 20th century, Voyager flybys in 1979 and the 1980s, that we understood the truth. This isn't a solid ring. It's a massive, shifting cloud of ice and dust. Then Cassini arrived in 2004. And suddenly, everything changed. For the first time, we could watch Saturn's rings up close, over years, in high detail, and what we saw was surprising. The rings aren't static at all, they behave more like a gigantic particle factory. Every second, countless ice grains are being shuffled around by gravity, collisions, and resonance. It looks peaceful from far away, but up close it's more like rush hour traffic on steroids. No brakes, no lanes, just gravity writing the rules. One of the most striking features is the Cassini division, the wide gap slicing through the rings. At first glance, it looks empty. But Cassini data showed something more subtle. It isn't empty at all. It's just extremely thin. And that gap exists because of long-term orbital resonances that slowly clear out particles. In other words, some regions don't stay put, they get cleaned over time. And here's where Mimas quietly enters the story. This small icy moon, only about 397 kilometers wide, turns out to have a surprisingly strong local influence. Through repeated gravitational nudges, it disturbs particles in the inner ring system. When a particle's orbit locks into a simple ratio with Mimas, resonance kicks in. And resonance is basically bad news for stability. It's like being pushed at exactly the same rhythm over and over again. Eventually, you drift off course. As the saying goes, repetition is the mother of learning, but in space, repetition can also be the mother of orbital chaos. Over long timescales, those tiny nudges add up, particles slowly leave certain regions, and gaps like the Cassini division emerge. So what looks like a natural empty space is actually a long-term sculpting process. And Mimas? It's one of the invisible hands doing the carving, not explaining the system, just rearranging it. But things get more complicated when we turn back to Mimas itself. Cassini didn't just take pictures. It tracked precise orbital behavior for over a decade. And something subtle showed up. Mimas wobbles. Not much, but consistently. In physics terms, it shows libration, a slight rocking in its rotation relative to its orbit. A perfectly rigid ice ball shouldn't behave quite like this. So scientists started testing explanations. Maybe its internal mass isn't evenly distributed, maybe there's a slightly offset core, maybe the ice layers aren't symmetrical. But none of these models fully match the data. Something always remains unexplained. So another idea enters the discussion: maybe there's a softer layer inside, possibly even a low-temperature liquid region. But that immediately clashes with what we see on the surface. No cracks, no plumes, no signs of geological activity, just a heavily cratered ice world that looks frozen solid for billions of years. So we get a strange contradiction: a completely still exterior, but hints of internal motion. Scientists are split on this. Some argue the wobble comes from measurement limits or model simplifications. Others think repeated observations suggest something is genuinely missing from our picture. Because Cassini gives us indirect evidence only. No drilling, no seismic sensors, no direct imaging of the interior. It's like trying to understand a locked room just by listening to echoes outside. You can make educated guesses, but you can't be certain. Then comes a more daring possibility. What if there really is a subsurface ocean? Originally, this idea wasn't even about life. It was about fixing the math. When rigid models fail to match orbital data, small but persistent errors appear. Add a fluid layer into the model and suddenly, the numbers improve. That alone made the idea worth considering. The likely candidates are salty water or ammonia-rich mixtures, because in the extreme cold of Saturn's system, pure water freezes easily. But salts and ammonia lower the freezing point dramatically, so liquid layers become physically possible. Some models even suggest a global ocean, tens of kilometers thick ice on top, rock below, and a slow-moving liquid layer in between. But again, this is still model-based, not direct proof. And then comes the time problem. If this ocean exists, it might actually be young, only tens of millions of years old, practically recent on a solar system scale. Yet the surface tells a completely different story. It's heavily cratered, meaning it looks ancient. So we end up with a paradox: an old surface, possibly young interior. Where does the heat come from? The leading explanation is tidal heating. Saturn's gravity constantly stretches and compresses Mimas, generating internal heat, like bending a metal wire repeatedly until it warms up. Over long periods, that could sustain pockets of liquid. We see similar processes on Europa and Enceladus, both candidates for subsurface oceans. But here's the difference: those worlds show clear surface activity. Cracks, plumes, energy leaking out. Mimas doesn't. It stays silent. That's why scientists sometimes give it a strange label. One of the least likely worlds to have an ocean, that might still have one. Because it offers no clear evidence either way. It simply sits there, letting the data contradict itself. And if all of this is true, then something bigger follows. Our definition of that icy worlds might be incomplete. Because beneath a surface that looks completely still, slow and hidden processes might still be active. And Mimas becomes exactly that kind of object: quiet, minimal, and difficult to read. It doesn't explain itself. It just keeps orbiting Saturn, as if nothing unusual is happening at all. If you rewind the clock far enough, Mimas starts to look suspicious. Not in a dramatic way, but in a quiet, unsettling one. It may not be a naturally born moon at all. It could be something assembled. Almost like a cosmic kit that got put together after the fact. And here's the uncomfortable idea: in the early solar system, around 4.5 billion years ago, Saturn's neighborhood was pure chaos. No neat orbits. No stable moons. Just constant collisions, ice bodies smashing, breaking, and reforming again and again. As the saying goes, nothing stays the same forever, and back then, that was literally true. Out of that chaos came a bold idea: Saturn's rings might not be original at all, they could be the leftovers of destruction. Voyager flybys in the late 20th century made this idea harder to ignore. The rings turned out to be extremely pure, mostly water ice. But that created a new problem. Because if they were truly ancient leftovers, you'd expect more dirt, rocky material mixed in. So another possibility emerged: maybe the rings came from a destroyed moon, or several. And once you accept that, Mimas suddenly becomes part of a much stranger story. Some models suggest Saturn once had larger icy moons that didn't survive. Tidal forces, impacts, orbital instability, something tore them apart. But gravity doesn't just erase things, it rearranges them. The debris didn't disappear. It got trapped and spread into rings. And over millions of years, something even stranger can happen. The fragments can slowly reaccumulate. Gravity starts pulling pieces back together, forming new small bodies. In other words, moons can be destroyed and rebuilt. Broken pieces can still make a whole, as the saying goes, and space seems to take that literally. If this is true, then Mimas might not be a pristine original moon. It could be a rebuilt object, a leftover from catastrophe, or even a mix of multiple sources stitched together. And that would explain something important: why its interior doesn't behave like a simple, uniform object. In a reassembled body, structure wouldn't be smooth or consistent. Large fragments could form a core. Smaller debris fills the gaps. The result is uneven, messy inside. Not broken, just not perfectly built in the first place. And that irregularity could help explain the tiny orbital oddities Cassini detected. Not because something is wrong, but because the structure is not cleanly ordered. But the real twist is time. If Mimas was rebuilt, then its age becomes confusing. The material itself could be ancient, but its current shape might be much younger than the solar system. Old ingredients, new construction. That's a strange combination and not an easy one for planetary science. It even becomes a philosophical question. If something is broken and rebuilt, is it still the same object, or just the continuation of its material, not its identity? Then the more practical questions begin stacking up. Is there really a subsurface ocean? Right now, the evidence is indirect orbital data, gravity models, subtle wobbles. Nothing direct. What is the interior actually like? A uniform ice sphere, or a layered rubble structure? Cassini hints at the second, but we can't confirm it. How did it survive massive impacts that should have shattered it? The Herschel crater suggests an event that should have destroyed a smaller body, yet it didn't. Maybe, as the saying goes, what doesn't break you makes you stronger, but in physics, that still needs an explanation. Then there's the most puzzling issue of all. Why is the surface so quiet? If something is happening inside, why does nothing show outside? No cracks spreading, no eruptions, no obvious surface response. It's like all the change is locked away where we can't see it. Put all of this together, and you get an uncomfortable picture. A world that looks simple, but may have a chaotic origin. A sphere that appears stable, but might be structurally complicated underneath. A moon that looks boring, but probably isn't. And when you return to the image of it, just a small icy body drifting near Saturn's rings, it doesn't feel so ordinary anymore. Because now you know it might have been destroyed, reassembled, maybe still changing, just far too slowly for us to notice. So the question becomes simple, but hard to answer. What is it really? A dead ice ball drifting in silence, or a world still quietly hiding its own reconstruction story? The people who change the world usually just think one step deeper. If this story made you see things differently, hit like, subscribe, and save it. See you in the next story.